Example number 3 is a true AP level problem. So you're given the name of a compound, hexamethyldiamine, its molar mass, and that it's made of carbon, hydrogen, and nitrogen atoms. You know the initial mass of the compound, and then we're burning it in oxygen. So this combines some chemical equation information. So when you burn something that has carbon and hydrogen in it, you're going to get carbon dioxide and water. So that piece is very important. So ultimately, my goal in this problem is to figure out how many carbons, hydrogens, and nitrogens they are. I need to use this combustion information. So I'm taking this compound and I'm burning it in oxygen to create CO2 and water. So I need this information here to help me kind of organize my problem. So I have an initial amount of 6.315 grams of this, and I'm making 14.36 grams of CO2 and 7.832 grams of water. So this is just helping me organize all of these numbers in the problem. And trying to digest it because there is a lot of information given in this problem. So ultimately, it's a molecular formula problem, so it's going to look similar to our empirical formula problem. So I need to start with how much CO2 I have. What's different about this is I don't really care how much oxygen there is because some of this oxygen, or I should say all this oxygen, is coming from another compound or another element that I'm not really concerned about. So I just need to know how much carbon is here. So we're going to use something that looks like a percent composition problem. So I'm going to have a bottom number that looks the same. So 44.01 grams is the amount of grams in CO2, but this time I'm not setting it equal to 1 mole. I want to know how much of this is carbon. So out of this 44.01 grams, I have 12.01 grams of carbon. So if I were doing the molar mass and just figuring out how much carbon contributes, that's what I'm using in this problem. There's a lot to this problem, so I'm going to recommend that you just watch the entire video and then go back through and take the notes on it, and that'll help you space it. I would write really small. There's a lot to this problem. Okay, so once I do that, I can calculate how many grams of carbon I have, and that's important. I'm doing a little bit of extra labeling with this one, just so I'm keeping track of where they are. Okay, I'm going to go through the rest of my empirical formula processes. I really need to know moles of carbon. So while I'm on this bridge, I'm going to add to it and just go the whole way out to my molar mass, or my molar problem, using the molar mass of just carbon. So this is how much carbon, so I'm using the molar mass of just the carbon to get the moles of carbon. So that part in getting to moles is the same because it is an empirical formula problem. I need to know how many moles of carbon I have. I'm going to go through the same process with the water. So I'm going to start with the grams of water. Now, you'll notice in water's formula there's 2 hydrogens. So up here there was only 1 carbon, so I have 12.01 grams. So when I go to do the hydrogen, I'm going to have to do 2 times the 1.01, and I'm going to use 2.02 grams of hydrogen for the whole molar mass of water, which is 18.02 grams. Okay. So from there, I calculate my grams of hydrogen. So I'm just going to calculate that out and get the 0.8779 grams of hydrogen. And continue like I did up here and go to moles of hydrogen. So notice I'm dividing by the molar mass of hydrogen, not the 2.02, because this is going back to what is 1 mole of hydrogen. So in an element, or in a compound, I always use the 1.01, not the 2.02. I think that's the most confusing part. And again, calculate the number of moles of hydrogen I have. Now, normally we'd stop here, but notice this sneaky problem has a third element and nitrogen. They haven't given us any combustion information about nitrogen, so this is applying the law of conservation of matter. So if I know that 6.315 grams is the entire compound, I know the grams of carbon, and I know the grams of hydrogen, I'm just going to subtract. So I know that these 3 added together are the 6.315. Subtracting out my carbon, subtracting out my hydrogen gives me my grams of nitrogen. So they don't give it to me directly, but I can use law of conservation of matter to determine that. Okay, once I know grams of nitrogen, I'm back to my same old process. nitrogen is not in a compound, so I only need to use my normal molar mass problem. So 1 mole is 14.01. That gives me my 0.1084 moles of nitrogen. I'm good to go there. Okay, so now I have the moles of each one of my formulas. Okay, and I am just going to do a regular empirical formula problem. So 0.1084 was my lowest number, so I'm dividing each one of those moles by that 0.1084. Gives me 3 for my carbons, 8 for my hydrogens, and 1 for my nitrogens. So that gives me my formula of C3H8N. Now, I also need to get molecular formula, so I'm still not done after all of that. So I'll calculate my molar mass of this whole formula. Okay. You never have to show work for this on the AP exam, but I just wanted to show you where I was getting this number. So if you can look on the periodic table and just calculate 58.12 grams, that's all you need to do. Okay, and then going back to my problem, so remember that big italicized M is molar mass. I have 116.2 grams per mole for my compound, so I'm going to take that number and divide it by my 58.12, which gives me a multiplier of 2. So 3 times 2 is going to give me 6, 8 times 2 is going to give me 16, 1 times 2 is going to give me 2, and I have my entire formula of C6H12, C6H16N2.